Okay, in doing transformations, as was said in class, you need to have this chart out. So either take a picture of it on your phone or have it printed out on a sheet of paper when you're doing these exercises. Okay, so I'm just going to go through these. Let's look at f of x minus 2. Okay, so let's come over here to the blank one. And let's find f of x minus 2. Now, you need to ask yourself, what is the difference from f of x and f of x minus 2? Well, you've subtracted 2 from the formula. So if you've subtracted, that's the second one here, if your function is changed by subtracting something, you shift down those numbers of units. So we're going to come back here to here, and what we will do is we start with the black one and we shift it down 2 units. So just going from left to right, we look at the points of interest here and down 2 units. It should be in red, sorry. This one, shift down 2 units, and then connect as you go. This one, shift down 2 units, and connect as you go. And that one, shift down 2 units, and connect. So what I've drawn in red there is the graph of f of x minus 2. Okay, so now what if I have something like this, f evaluated at x plus 3. I'll come here. And you're asked to draw the graph of that. Well, how do we get from f of x to f of x plus 3? And we do not add 3 to the equation. If we were adding 3, we would have had that. And as you can see, that's not what we have there. So what has changed? Well, what has changed is the change to get from f of x to f of x plus 3 is we have replaced the x in parentheses with x plus 3 in parentheses. So if we go to the sheet, and here's the third one, I have replaced x with x plus 3. So I'm going to shift 3 units to the left. So we're going to have a left shift if you replace the x with x plus k. So let's come back here, which is what has happened. And so we're going to take each point and we're going to shift left 3 units. So here I'm going to have 1, 2, 3. Here I'm going to have 1, 2, 3, and then connect as we go. This point I'm going to go left 1, 2, 3, and connect as we go. And then this point I'm going to go left 1, 2, 3, and connect as we go. So what I've drawn in red there is the graph of f evaluated at x plus 3. Okay, so what are we going to look at next? What did they look at next in the notes? Okay, something like this. All right. So what if we've been asked to draw that? Now, how do you get from this formula to this formula? Well, you've multiplied by 2 on the outside. you've multiplied the entire formula by 2. So look at the chart, and right here, multiply entire formula by k, so see how k is on the outside. Then the point on the original function will be transformed into a new point. And if you can see here, the x coordinate does not change. The y coordinate will change, and the way you change it is you take the original y coordinate and you multiply by whatever that number k is out the front. So I'm going to come back here, and according to my chart, if I have a point on F, it's going to be transformed into a new point. The x coordinate will be the same, but I'll get a new y coordinate, and it's going to be the old y coordinate times the number out the front. So down here, I am going to make use of these points that I had listed there to get my new points. So first of all, the x coordinates do not change. Comma, 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 comma. Then I will get new y coordinates. What's the new y coordinate going to be? It's going to be the old y coordinate times 2. So -1 times 2 is -2. 2 times 2 is 4. 1 times 2 is 2, and 1 times 2 is 2. Now I'm going to plot these points and connect them as I go. So -2, comma, -2, -1, comma, 4, and I'm going to connect as I go. Then 2, comma, 2, connect as we go, and 3, comma, 2, connect as we go. So what I have there in the red is the graph of that one. Okay, now what if you're told to draw that? Well, it's the same thing as the one I just did, except we had a 2 out the front. Now your entire formula is multiplied by -1, but they haven't written it like that. It will never be written like that. It's just negated, but we understand that we have a -1 outside the front. So since we have a -1 outside the front, we're in the same case that we were in the last example. A point on f of x will get transformed into a new point. I have -1 out the front, so my x coordinate is unchanged, but my y coordinate will be the old y coordinate times -1. So I'll have my new points. My x coordinates will all be the same, but my y coordinate's going to be different, and I'm just negate them or multiply them by -1. So the negative of -1 is going to be +1. Then I'll have -2. Then I'll have -1 and -1. So now I'm going to draw these new points and connect them as I go. So -2 and +1, -1 and -2. And so connect as we go. 2, comma, -1, and connect as we go, and 3, comma, -1, and connect as we go. And so what I've drawn there in red is the graph of -f of x, which is its reflection in the x-axis. So that's a special one. Take the black one and flip it in the x-axis, and you get the red one. Okay. Now, what if I have, if I'm asked to find this? Okay, now we have not multiplied the front out by 2. What's the change? The change is we have replaced x in the parentheses with 2x in the parentheses. And so if we use the chart, that's down to this one, the next to last one. Replace x by k times x, some number k. So a point on my original graph, now it will keep the same y coordinate. It will have a new x coordinate, but be careful here, it's not going to be k times x, it's going to be 1 over k times x, so per the rule. So let me apply the rule to this one. So what the template says is a point on F is going to be transformed into a new point. It will have the same y coordinate, but now I'm going to have a different x coordinate, and it's going to be the old x coordinate times 1 over this number, the flip of that number. So I am going to need to put my new points. So I'm going to keep the same y coordinate. So all of them will have the same y coordinate. Oh. I'm keeping the same y coordinate for all of them. Now I'll have a different x coordinate. My new x coordinate is going to be the old x coordinate times a half. So -2 times a half is -1. -1 times a half is -1/2. 2 times a half is 1. 3 times a half is 3/2, or 1.5. That's fine. Now I'm going to plot these new points and connect them. So -1, -1, then -1/2, comma 2, and I'm going to connect as I go. Then 1, comma 1, which is there, and then 3/2, comma 1, or 1.5, comma 1. So what this has done is it's taken the black one and it's squeezed it, compressed it like an accordion. And again, what is in red is what we have there. Now, what if I change this? And we're told to draw that. Okay, well, how do we get from here to here? We've replaced x with negative x, which is -1 times x. Okay. So from our chart, my original points on function f will become new points. They will have the same y coordinate, but the x coordinate will be new, and it's going to be the flip, the old x coordinate times the flip of -1. Well, the flip of -1 is just -1. So my new points are going to be, well, the y coordinates are the same. The y coordinates are the same. And the new x coordinate is going to be the negative of my old x coordinates. So the negative of -2 is 2. The negative of -1 is 1. Then I'll have -2 and -3. So now I'm going to do 2, comma -1, 2, comma -1, then 1, comma 2, and I'm going to connect as I go. Then I'm going to have -2, comma 1, and -3, comma 1, and then connect. So what I've drawn there in red is f evaluated at -x. Okay. All right. So now let's come down. We've done a lot of these. Okay. All right, what if we want this one, f of x minus 2 plus 3? Okay. F of x minus 2 plus 3. Well, we can't get there in one step. So the path I'm going to take is I know how to get that. So how do you get from black to blue? Well, I've replaced x with x minus 2, and according to the chart, that's going to be a shift of 2 to the right. Then let's look at the blue one. If I just change the blue one by adding 3 to it, my new formula is going to be that. But if I change the blue one just by adding 3 to it, then according to my charts, that's going to be 3 units up. So I can get from the black to the red. I can get from the black to the red if I do each of these steps. So go 2 right, 2 to the right, then go 3 up. And I'm going to do that with each of these points here. So I'm going to start here. I'm going to go 2 to the right and then 3 up. With this point, I'm going to go 2 to the right and then 3 up. And now I'm going to connect as I go. With this point here, I'm going to go 2 to the right and then 3 up. And connect as we go. And then this last point, 2 to the right and 3 up. So what I have drawn in red on the graph is what the graph of that looks like. Okay. Now, what if I have, if I'm told to find this? I can't get there in one step, but I can get there in 2 steps. So if I start with f of x, and then I get this, well, to go from black to blue, I'm replacing x with x plus 3, so that's going to be 3 to the left. And then if I take the blue formula and negate it, multiply the whole thing by -1, then a point on the blue graph will get transformed. Well, it's multiplied by -1 on the outside, so the x coordinate will stay the same according to the chart, but I'll have a new y coordinate, and the new y coordinate of this blue point will be -1 times the blue y coordinate, so minus y. Okay, so let's see what we can do. I want my blue points. So I'm going to start here and go 3 to the left. So that's -5, comma, -1. Then this one and go 3 to the left. And then connect. And then that point's going to be -4, comma, 2. Then take this one and go 3 to the left, 1, 2, 3. And that point is -1, comma, 1. And connect it there. And then this point and go 3 to the left, 1, 2, 3. And that point has coordinate 0, comma, 1. And then connect. So the way I'm going to get from the black to the red is I go from the black to the blue, and then we want to go from blue to red. So the red is going to be the negative of the blue equation. So My points in blue are going to become, I have the same x coordinate, but the y coordinate is going to be negated. So I'm going to have the same x coordinate, but the y coordinates are going to be negated. So the negative of -1, I'll have -2, I'll have -1 and -1. So I want to plot the red points, and that will give me the red graph. So -5, 1, -4, 2, -4, -2, and then we want to connect. And then we have -1, -1. Excuse me. Connect. And 0, -1, which will be there. So I can get rid of the middleman. I don't really care what's happening to the blue now. And I have the graph of my red one, which is -f of x plus 3. Okay. And finally, what if I have something like, you're told to find that. Okay, well, this is the last one on the chart, but it's actually made up of the previous two cases together. So if I have a point on my original black function, I am going to get a new point because there's a 3 multiplied out the front. That will change the y coordinate, and the y coordinate will be the old y coordinate times 3. Now inside we go from x to 2 times x, so I will have a new x coordinate, but the number out here is going to be 1 over 2, the flip of 2. Okay, so I should have my new points. With my x coordinate, I'm going to be multiplying them by a half. -2 times a half is -1. Oops, they're in red, sorry. Okay, so my new x coordinates are going to be 1/2 times the old x coordinate. -2 times a half is -1. -1 times a half is -1/2. 2 times a half is 1, and 3 times a half is 3/2, or 1.5. Now, my y coordinate is going to be 3 times the old y coordinate. So 3 times -1 is -3. 3 times 2 is 6. 3 times 1 is 3. And 3 times 1 is 3 again. So those are my new points. I'm going to plot them. -1, -3. -1/2, 6. And then I'm going to connect them as I go. And then we're going to have 1, 3. 1, 2, 3. So connect as we go. And then 3/2, 3, or 1.5, 3. Okay, and so for the last example, that is going to be what you see in red there, the graph of 3 times f evaluated at 2x. Okay, so hopefully that's enough of an assortment. Have your charts out, and if it takes more than one step, show me how you divided it up, and use that email instructor button if you need any help.